Alright, here's another interval of convergence problem. We're going to find all x values such that the given series would converge. Now there's an n factorial in the numerator of this term inside of this series. So this might tip us off right off the bat that we're not going to have a very big interval of convergence here. But let's see what happens using the ratio test. As we did in the first two interval of convergence videos, we took the term inside of this infinite series and we replaced n with an n plus 1 and we stuck that in the numerator. Then we just took that term inside the series and put it in the denominator. Then off to this side, we think about the algebra that we need to do to simplify. For example, x minus 6 to the power n plus 1 can be split up into x minus 6 to the power n times x minus 6. We also know that n plus 1 factorial can be written as n plus 1 times n factorial. If we do those two things, you'll notice that we get some cancellations. The x minus 6 to the n powers cancel, and the n factorials cancel. And let's see, that leaves us with an n plus 1 and an x minus 6. And oh, don't forget we have a limit as n goes to infinity. Now as n gets bigger and bigger, this term is going to go to infinity. This is always greater than 1, so that means that our series is going to diverge for all x values except there's one sneaky x value where this limit actually doesn't go to infinity. When x equals 6, this term is 0, so the limit as n goes to infinity is actually 0. And our series would converge. Of course it would just converge to 0, which isn't that interesting. So by the ratio test, the only way to get this series to converge is if we plugged in x equals 6. And that is it. That is the final answer to this problem. Let's do some slightly harder problems in the next videos. I'll see you there.